Well, hello, mathematicians. Welcome back. Today we're going to be talking about finding equivalent ratios using multiplication and division. You've already done a little bit of multiplication, so I just want to give you an opportunity to check your work. We have the ratio in front of you of 2 to 3, and I'd like you to find equivalent ratios using the factors 3, 4, and 5. Go ahead and pause the video, do the work, and then come back to me. Well, if you're listening to my voice, now we're talking about what are the equivalent ratios that we can find when we multiply the terms by 3, by 4, or by 5. So the way this works is that you simply multiply each term by the factor you choose, and that will give you a new equivalent ratio. So 2 times 3 is 6. And 3 times 3 is 9. So 2 to 3 is equivalent to 6 to 9. And if you do the same thing using the factor of 4, you're just going to multiply both 2 and 3 by 4 and come up with a new equivalent ratio of 8 to 12. Right? 2 times 3, 8. And 2 times 4, 8, and 3 times 4, 12. So far, all of these are equivalent. And now we're going to multiply both terms by 5. 2 times 5 being 10, 3 times 5 being 15, and our equivalent ratio is 10 to 15. All of these now can be written as fractions. 2/3 is the same as 6/9, is the same as 8/12, is the same as 10/15. All of these have the same relationship to each other, and 2/3 in this case is the simplest fraction, or 2 to 3 is the simplest ratio. All right? Well, that's multiplication. What about division? Here you see on the screen in front of you a ratio that's 18 to 54. Now, when we are making equivalent ratios by division, what we like to do is look for the greatest common factor, which will help us determine what the common factors are. So go ahead and find the greatest common factor of 18 and 54, then come back to me. Well, using the latter method, you see that both of these are even numbers. And as long as you have even numbers, you're able to take out a prime factor of 2. And so we have 2 times 9 being 18, 2 times 27 being 54. And these are not both even, they're odd. So we can take out a common factor of 3. 3 times 3 being 9 and 3 times 9 being 27. And we have one more factor of 3. 3 times 1 being 3, and 3 times 3 being 9, and now we're done. The numbers over here, as you know, are the greatest common factor between these two numbers, and that is 2 times 3 times 3, and we know that 2 times 3 is 6, times 3 is 18. So the greatest common factor of 18 and 54 is 18. Now, the secret to this is that once you have the greatest common factor, you have all the common factors of the two numbers, because the factors of the greatest common factors will be factors of both of the numbers. And for our purposes, we're not going to use 1, because 1 times any number is the number itself, and we are looking for equivalent ratios that are not the same ratio we started with, ratios that have a different name but the same value. So we're not going to multiply by 1, but we will use all the other common factors to help us. So let's go ahead and get started here. The first common factor that we found was 2. And I'm going to go ahead and list all of them here just to make it easier. I think it was 2, 3, 6, 9, and 18. Okay? And what we're going to do, just like we did in multiplication, we are going to divide each each term of the ratio by the same factor in order to get differently named ratios that are equivalent. All right. So in this case, 18 divided by 2 is 9, and 54 divided by 2 is 27. All right. So 18 to 24 is the same ratio actually as 9 to 27 is. They are equivalent. Right? And if we continue and divide each term by 3, 18 divided by 3 is going to be 6, and 54 divided by 3 is going to be 18. So 6 to 18 is another equivalent ratio. And if we continue and so on down the list, then we can go ahead and divide the terms, both of them, 18 and 54, by 6. And when we do that, we're going to get 3 to 9. And we can divide both of them by 9. When we divide 18 by 9, we'll get 2. And 54 by 9 divided by 9 is 6. And lastly, dividing by our greatest common factor, 18 divided by 18 is going to give us 1, and 54 divided by 18 is going to give us 3. All right. So these are also equivalent ratios rather, 3 to 9, 2 to 6, and 1 to 3. 1 to 3 being our simplest ratio. All right. So 18 to 54 in simplest form is 1 to 3, but all of these ratios are equivalent. And you've seen these kind of equivalencies before, right? You've seen them in fractional form, but it's true also in ratio. Well, now it's your turn to try this. I have two numbers on the screen in front of you. 24 to 96 is the ratio. Remember, step 1 is to find the greatest common factor, and step 2 is to divide by the common factors. If you find the greatest common factor, you find all the factors. Go ahead and give it a try. Pause the video, then come back to me. Well, hopefully when you were dividing or doing your prime factorization, you were able to see that it broke down like this. Every time there's an even number, of course, you're able to divide by a 2. And once that you have one of the two numbers that is not even, then you go to the next prime number, or prime factor. So in this case, we have 3 gives us 1 and 4. All right. So now we're done. Our greatest common factors are here on the side, or our greatest common factor, is here on the side, and that's 2 times 2 times 2. Should be familiar to you. 2 cubed is 8 times 3, and 8 times 3 is 24. So our greatest common factor is, in fact, 24. These are the factors of 24. And the common factors which we will use listed here below. We've excluded 1 because there's no reason to do that when we're trying to find equivalent ratios. All right? So remember, very kind of key point here, that if you can find the greatest common factor, you have found all the common factors of the two terms of the ratio. So let's go back. We did say that the common factors were 2, 3, 4, 6, 8, 12, and 24. Now, dividing by the greatest common factor, 24, is going to give us our simplest form. All right, so let's go ahead and do that one first. 24 divided by itself is 1, and 96 divided by 24 is 4. So this ratio in simplest form is 1 to 4. All right. And everything in between here is equivalent to 1 to 4 or 24 to 96, all right? So I want you to go ahead and do those divisions and come back and check your work. All right, this is going to look like this. If we divide each term by 2, we get, 12 to 48. Each term divided by 3 will give us 8 to 32. Each term divided by 4 will give us 6 to 24. Each term divided by 6 will give us 4 to 16. Each term divided by 8 will give us 3 to 12. All right, this is, 24 divided by 8 is 3, and 96 divided by 8 is 12. That's what we're talking about, okay? 24 divided by 12 is 2, and 96 divided by 12 is 8. And then the last one, which we did first, 1 to 4. All of these are equivalent ratios. They're all the same as each other. They have the same value, name the same size, and are expressed in simplest form as 1 to 4. All of them equivalent to each other. Well, that's all I have for you today. I hope you have a wonderful day, and I'll see you again soon.